So today we're going to be going over lesson 10, session 3. So that's going to start on page 237 of your book. And as always, if you don't have your ready workbook, just keep notes on a scrap piece of paper. Your homework's going to be pages 241 and 242. And a reminder to make sure that you complete the second half of your math diagnostic on Friday if you haven't done so already. So the first problem is this try it problem that says that Tarek makes 2 large game mats for a beanbag toss. One mat is square and the other is an equilateral triangle. The square has a side length of this x plus 3. The equilateral has a side length of this 3x minus 1. It says the perimeters of the mats are the same. So remember the perimeters when you add up all the outside side lengths. So when you figure out what are the side lengths of each game mat, which we start by solving for x.
So for this problem, we see that they are making 2 large square mats for a beanbag toss. One mat is a square, like this, and the other is an equilateral triangle. The square has a side length of x plus 3, and the equilateral triangle has a side length of 3x minus 1. What that means is that the square, every single side length has that x plus 3. Since the square and all of the sides are the same, since this is an equilateral triangle, it means all 3 sides of the triangle have the same side length of that 3x minus 1. So they're saying that the perimeters are the same, and we need to figure out what the side length of each game mat is. So remember, a perimeter is adding up all of the outside of a figure. So if their perimeters are the same, that means that this x plus 3, when added together 4 different times, should be equal to this 3x minus 1 being added together 3 different times. So we can set the equation of that x plus 3 when added together 4 different times for the square is equal to that 3x minus 1 when added together 3 different times. And that's how we would set up our equation. From there, we want to do those distributive properties, so 4 times x and 4 times 3, and then 3 times 3x and 3 times negative 1. 4 times x will give you 4x. 4 times 3 will give you 12, so we have 4x plus 12 on one side, and then we have 3 times 3x is 9x, and 3 times negative 1 is negative 3 on that side. From here, we can see that there are no like terms on the left-hand side, and there are no like terms on the right-hand side. That's when we get to those inverse operations. We want to move our x values to one side, and then move our non-x values to the other side. So since we have this positive 4x here, you want to do the opposite and subtract 4x over here. And that will make this go away. So that, and then from here you have that minus 3, so you want to do the opposite, so you're going to add 3 over here, which will make this go away. 12 plus 3 is equal to 15, and 9x minus 4x is 5x, so we have 15 is equal to 5x. Then you have your final step of getting x by itself. You need to do the opposite of multiplication, which is division, so you're going to divide by that 5, which will make that go away, and x will be equal to 3. Now the next step is they want to figure out what the side lengths of each game mat are. So now that we know what x is, we want to figure out what is this side length, and then what is this side length. So we can see that for the square, we're using that x plus 3 for one side length, and since we figured out that our x was 3, we would just plug that into the equation, and so we can see that 3 plus 3 is equal to 6, so the side length of the square would be 6. And for our triangle, we have this 3x minus 1, so we're going to plug our x of 3 into that equation, so we do 3 times 3 minus 1, which gives you 3 times 3 is 9, so 9 minus 1 is equal to 8. So the side length of the triangle is 8.
So that's how you do that problem. Next, we move on to the connect it. So we go to connect it question 1, which is asking us to explain how the equation represents the situation. So we have that 4 multiplied by that x plus 3 is equal to that 3 multiplied by that 3x minus 1. The 4 represents the number of sides that we have in that square. And since each side length is x plus 3 and there are 4 side lengths, that's why you multiply them together. The 3 represents the number of sides in a triangle, and that 3x minus 1 represents the side length for a triangle. Since there's 3 of them, that's why you multiply it. And so since the perimeter of each is the sum of its side lengths, the square has 4 sides of that x plus 3, and the triangle has 3 sides of that 3x minus 1. The perimeters are equal, so that's why you set them equal to each other like so. Next, for problem 2, it's asking if the solution to the equation also the solution to the problem. So no, that's because the solution of the equation is x, so you're just solving for x. However, the solution to the problem is also the x plus 3 and 3x minus 1. So once we figured out that x was 3, to find the side length of the square, we had to plug it into that x plus 3 equation to see that 3 plus 3 is equal to 6, so that was the side length of the square. And then we had to plug x is equal to 3 into this equation as well to do 3 times 3 minus 1 to see the side length of a triangle is 8. Next, they're asking what the side lengths of each game mat is. Like I said, you want to plug what we solved for x, which we found out that x was equal to 3, into those different equations. So we see that 3 plus 3 is 6, and then that 3x minus 1 would be 3 times 3 minus 1 is 8. So the side length of a square was 6, and the side length of a triangle was 8. Then for question 4, it's asking how do you know whether the solution of an equation is also the solution to the original problem. So what you need to do is determine what the variable in the equation represents, and then from there see where the solution to the variable is the solution to the equation or if it needs further work to be completed. So we figured out what x was, and then from there we figured out that we needed to use that x to further find our solution. Next we have problem 6 for the apply it problem. So it's saying that James and his sister saved money for a trip to the water park. James has saved half the amount as his sister, and if they both save $30 more, James will have saved 3/4 as much of his sister. Which equation can you use to figure out how much James has saved? So again, we know that he started out by saving half the amount of his sister. So like we have this 1/2 x for A, C, and D here. And then they're asking if they both save $30 more, then James will save 3/4 as much of his sister. So once they add 30 more, he will save 3/4 as much, which is why our answer will be letter D here. Next we have problem 7, and it's asking how much money has James saved in problem 6. So then we're going to figure out the answer to x and then work it into our solution from there, as you'll see in this video.
So for question 7, we need to figure out how much money James saved in problem 6. So we're going to start off by solving for x here given this equation. So we have 1/2 times x plus 30 is equal to 3/4 times x plus 30. So here we can see that this cannot be simplified at all, so those are not like terms. However, we do need to distribute on the right hand side. So we need to do 3/4 times x and 3/4 times 30. 1/2 x plus 30 will stay the same on the left hand side. Then 3/4 x plus 30 is going to become 3/4 times x, so 3/4 x. And 3/4 times 30 is equal to 22.5. From there we can see that there's no like terms on the left hand side and there's no like terms on the right hand side, so that's when we go to those inverse operations. So now we want to get our x values onto one side and our y values to the other. So we're going to subtract 1/2 x from 3/4 x over here, so that this will cancel out, and then we're going to subtract 22.5 from 30 over here, so that this cancels out. So again, we have this positive 1/2 s, so you want to do the opposite and subtract 1/2 s, make this go away. And then instead of adding 22.5, we're doing this opposite operation and subtracting 22.5. Make this go away. 30 minus 22.5 is equal to 7.5. And 3/4 x minus 1/2 x is equal to 1/4 x. Then from there, that final step to get x by itself is to do the opposite of that multiplication. So you're going to divide by 1/4, so that this goes away. So that x is going to be equal to 7.5 divided by 1/4, and therefore x is equal to 30. However, we are not done there. See, in problem 6, it said that James and his sister saved money to the water park, and James has saved half the amount of money that his sister has. We found out that his sister saved $30 by finding x here. So if James made half as much, that means that he made 30 multiplied by that 1/2, which means that James made 15.
So that's how you do problem 7. Then lastly, we go to problem 8.
So for
question 8, we see the length of Adriana's chicken coop is that 3x plus 12 feet right here. The length of her garden is the 6x minus 16 feet here. And the garden is 2/3 the length of the chicken coop. So we need to figure out what are the lengths of the chicken coop and what are the lengths of the garden, as we'll see in this video right here.
So for this problem, we're saying that the length of Adriana's chicken coop is 3x plus 12 feet long, as it states here. And the length of her garden is 6x minus 16 feet long, and the garden is 2/3 the length of the chicken coop. We want to figure out what the length of the chicken coop and the garden are. So we need to set up our equation. So as we can see, we have our garden, which is 6x minus 16. And then our chicken coop, which is 3x plus 12. We are told that the garden is 2/3 the length of the chicken coop, which means we need to take the chicken coop and multiply it by 2/3 to set them equal to each other. From there, our first step, remember, is to distribute. So we do 2/3 times 3x and 2/3 times 12. So our left-hand side stays the same. So we have 6x minus 16. Going to be equal to 2/3 times 3x is going to be 2x, and 2/3 times 12 is going to be equal to 8. From there, we do not have any like terms on the left-hand side, and we don't have any like terms on the right-hand side, so then we go to those inverse operations. So we're going to move 2x over here. Then we'll move this negative 16 over here. So since we have positive 2x here, we need to do the opposite and subtract 2x over here, which will make this go away. So 6x minus 2x is 4x. And since we have a negative 16 over here, we need to do the opposite and add 16 over here. We'll make this go away. So 8 plus 16 is equal to 24. We have 4x is equal to 24. From there, that final step is to do the opposite of that multiplication. So we're going to divide. So 24 divided by that 4 will make this go away. So that x is equal to 24 divided by 4, which is 6. Now from there, they're asking us what are the lengths of the chicken coop and the garden. So what we are going to do from there is, again, we have that x is equal to 6. We want to plug it into those equations, figure out the length of the chicken coop, and then to figure out the length of the garden. So first, figure out the chicken coop. We have our equation of that 3x plus 12. We need to plug in our x value, which we found to be 6, so that we have 3 times 6 plus 12. When we plug that into our calculator, we do 3 times 6, and we get 18. Then we add 12. We see that our chicken coop is 30 feet long. Next, we do our garden. So again, that equation is that 6x minus 16. We want to plug in our x value, which we found to be 6. So we do 6 multiplied by our x is 6 minus 16. 6 times 6 is 36, and now we have 36 minus 16. We do 36 minus 16, you get 20. And as we said, the garden is 2/3 the length of the chicken coop. So if we put this into a fraction, we would see that 20 over 30 does in fact equal 2/3. So we know that we are correct. So our chicken coop is 30 feet long and our garden is 20 feet long.
Then finally, our last thing is that your homework on pages 241 and 242 is going to be due tomorrow, January 14th at 9 a.m. If you have any questions, please let me know and I'll be happy to help. Other than that, have a good day. Bye.